So the first one is we need to evaluate the limit, and I apologize if it's so simple, but you've done this before. X squared minus 16 over x minus 4. And you can see that this is indeed, when you plug, if you do direct substitution, you have 0 over 0. Right? So it looks like, on the face of it, it looks like indeterminate form. So you have 16 minus 16, so you have 0 divided by 0. But on the other hand, if you factor, so this is actually, forget about it, this doesn't apply, because if you factor it, you have x minus 4 times x plus 4 divided by x minus 4, and after simplification you end up having the limit as x approaches 4 of simply x plus 4, and you know it's equal 8. So this was a very, very quick solution. The next one, it may not be so obvious. It's the limit as x goes to infinity, so it's a limit at infinity. And here we have 4x squared minus 5x divided by 1 minus 3x squared. Okay, so this appears to be a kind of limit that we have infinity on top and infinity at the bottom. So on the face of it, it appears to be this type. But what we know about limit at infinity, if x goes to infinity, we'll have to have 1 over x, 1 over x squared, or 1 over x cubed, something like that, because all of those expressions will go to 0 as x goes to infinity. So we need to factor. Normally what we do in this case, we factor the highest power, and let's say this is the same as the limit as x goes to infinity, and the highest power is x squared. So we factor x squared, we have 4 minus 5 over x divided by, again, factor the x squared, and get 1 over x squared minus 3. And after simplification, you have the limit as x goes to infinity. Of course, x squared and x squared are being reduced, and now you have 4 minus 5 over x in the numerator divided by 1 over x squared minus 3 in the denominator. And this makes us very happy, because the as x goes to infinity, 5 over x goes to 0, and 1 over x squared goes to 0. So, and we end up having negative 4 over 3. Okay? So those are very simple cases.